We have a cluster of the earthquakes at a depth of the 1 kilometer to around 6 or 7 kilometers. And when we look at the map of the concentration of these earthquakes, we see that they are concentrated in the Reykjanes Peninsula and specifically near the Hengill volcanic system. This cluster is at a depth, as I mentioned, of mostly around 5 kilometers. And the magnitude of them actually is very interesting. They're tiny. They can be related to a movement of the magma within that area. Of course, this is the volcanic system which is famous. In the past, it had erupted. And when we have one eruption, which is currently we have it in the Svartsengi, the pool of the earth crust creates activity in the adjacent volcanic systems. So Svartsengi, when it has eruption, next we'll have Brennisteinsfjöll, next we may have the Hengill or Brennisteinsfjöll, and then Hengill, and then goes toward the north. This is a spreading of the earth crust, lithosphere, as you can see, and through that extension, we have the mid-Atlantic ridge, which a microcontinent of the Iceland is actually sitting on the top of it. So it's created this Reykjanes Peninsula in that area, adjacent to that microcontinent. And we have one eruption in this area, for example, Svartsengi. The next one also will happen in the adjacent toward the east area. Most of these are on the Eurasian plate. I have a video about this. Please watch this. We have started the day by a series or a cluster of the earthquakes concentrated around the Hengill volcanic system in the Reykjanes Peninsula of Iceland. The depth of most of them is around 5 to 7 kilometers, and they are concentrated around the Hengill area. This is the area marked for you now. You can see this, and they are concentrated also on the short period of time. Very sharp concentration you can see there, almost like one of those cases that we had an eruption. It's interesting at this time also, we had 1 kilometer depth earthquake on the ground zero in the Grindavik. That's the area that we are expecting an eruption any moment, related also to the another volcanic system called the Svartsengi volcanic system. These are from the movements of the plates and transferring of the movement through the transform fault. Those black arrows shows them through the volcanic system in this Reykjanes Peninsula of Iceland. I have a video about the Hengill volcanic system and the importance of it. You please watch this video and remember that this is the area tectonically active. We are seeing land being built. There is a very common mistake according to which in Iceland we have the boundary between the American plate and Eurasian plate. This is wrong. And why? Because we have another plate, a less known plate between these two. It's a microplate. It's called Hrapar microplate. This is where we have no earthquakes, no volcanism, yes, no volcanism, and no tremors of any kind that can actually threaten the life. Of course, this is in the central parts of the Iceland, where the western volcanic zone and the southern volcanic zone come in contact. The triple point of that is bounded what we call as Hengill volcanic system. This is a nasty volcanic system, one of the biggest of the sequence of the volcanic systems in the Reykjanes Peninsula. It had erupted last time in 2,000 years ago, and it has a large lava field. Because it's close to the glacials, it can be potentially explosive. At the moment, it is a source of the geysers, the geothermal fountains of hot springs, as you can see here. And they can erupt to a beautiful height, several hundred meters sometimes. This is because at the depth, the groundwater comes in contact with the rocks which are heated by the magma from the previous eruptions. This is practically the lower to the middle part of the ophiolite system that we know from the Oman, Cyprus, Iran, America, Australia, even Britain. These are the areas that the volcanic eruption happened in the past. Of course, this Reykjanes Peninsula has been active over the past few years. We had the Fagradalsfjall, Merardillu, Litlukotor, Sundunka, Hagafell, Grindavik, and again Sanduka 2 eruptions happening one after another. These volcanic systems are extending where the earth crust is extending and getting thinner and opening up a way for the magma to rise, to form actually by the melting of the top part of the mantle and rise and erupt as lava. Each volcanic system on its own transfers the movement, the thinning of the ground from one system through this process of badinage, means sausage making. These are like a sausage rolls twisted at certain points, starting from the Atlantic Ocean in the Reykjanes Ridge, and then earthquakes transfer through that ridge to the Reykjanes Peninsula and through every single volcanic system that we have there: Elfdorf, Svartsengi, Fagradalsfjall, Kristuvik, Brennisteinsfjöll, and the last one is Hengill one. And the Hengill after that is a triple junction for the south and the western volcanic zones. So transferring of the movements happens there. Hengill is the last in the chain. When the others have erupted, Hengill will be the last one to erupt. And when the others have the tremors and movement, Hengill will be the last one to receive the movement, to accommodate the movement. Otherwise, practically, they cannot move if they don't accommodate this movement. Hengill is always the last. So in that sense, we can say that this is difficult to move the Hengill. And now the Hengill, we have earthquakes in that area, which is now moving. The transformation of the movement from the Reykjanes Ridge to the Reykjanes Peninsula is not completed. And as the time goes by, when the Kristuvik volcanic system is awakening, next is the Brennisteinsfjöll activated, and then the Hengill volcanic system. One by one, they will erupt in the future over the next decades, probably.